Hey guys, it's Mr. Walker here at the home studio again, and today we're going to be talking about rounding again. Okay, so we've been doing a lot of practice with rounding, right? And in previous lessons, we worked with rounding using the vertical number line, and then we worked on rounding without using the vertical number line, and just some different strategies that we can use to round numbers to different places and use them as estimates, especially when we're problem solving. Well, today we're actually going to do some problem solving, and we're going to kind of look at how we can use rounding and estimating to help us to solve problems. But the first thing we're going to take a look at is how we can round numbers to different place values again. We're just going to review that real quick. So make sure that you have a whiteboard, something to write with, something to write on, and that maybe you have a learning guide or a partner or somebody close by that you can kind of talk with and ask some questions to, because we're going to be doing a little bit of discussion today. So it'd be good to have that. All right, so if you have those things and you're ready to go, let's take a look at these numbers that I wrote on the board. So you can see I have the same number written 3 times because we're going to round it to 3 different place values. Now the first thing that I want you guys to do is practice reading this number aloud, okay? Pay attention to your periods, your commas, and practice reading that number aloud. All right, awesome. So this number, as I would read it, would be 935,292, okay? 935,000 because it's in the thousands period, 292. Now for our first number written here, we're going to round to the hundred thousands place, okay? So the first one, we have a 9 in the hundred thousands place. So if we think about that, the low end of that number is going to be 900,000. The top of that, if we're looking at that vertical number line, is going to be a million, okay? All the way up to a million, which is kind of crazy. So if we look, the midpoint of that is going to be 950,000, okay? 950,000 would be the middle. So anything above that we would round up, anything below that we would round down. Right here we're looking at 93, so 93 is definitely below 95, so we're going to round down for this guy. And if we rounded down, this guy would end up being 9. That 9 would stay the same, okay, and everything else would turn to 0, so we would have 900,000, okay? So if we rounded to the hundred thousands place, we would end up rounding down because of what comes next, which is that 3, all right? Okay, so let's take a look at that second number. Again, we have 935,292. This time we're going to round to the 10,000s place, which means we're going to be rounding to this place value here. So our 9 is going to stay the same, hopefully. Our 3 is going to stay the same. And we're going to have to pay attention to this 5 that comes next, okay? And our 3, actually, I'm sorry I misspoke, our 3 might not stay the same. It might change based on whether we have to round up or round down. So let's take a look. If I have 930,000, well, the low point of that is going to be 930,000. The high point to that is going to be 940,000. The midpoint is going to be 935,000. That's going to be our midway, our in-between point there. We're at 935,000, so we're right at that mark. So that means we're going to round up, okay? So that 9, so that 3 is going to round up to a 4. We're going to keep that 9 the same. We're going to round that 3 up to a 4. And then everything else is going to turn to zeros. Okay, so you can see just rounding to a different place value kind of changed our numbers a little bit. We went from 900,000 in our first one, rounding to the 100,000s place, to 940,000 when we rounded to the 10,000s place. So now let's take a look and round to the thousands place. I want you guys to do this on your own, and then we'll check back in together. All right, if I was going to round to the thousands place here, my 5 is in the thousands place, so that means my low point would be 935,000. My high point would be 936,000. So my midpoint would be 935,500. I would have 935,292. So that's below that 500, which means I'm going to keep this guy the same. I'm not going to round him up, so he would be 935,000. Perfect. Okay, so we can round to different place values. Okay, that's something I wanted to kind of review and just make sure you remembered. We can round to different place values, and sometimes, as we're going to see in some problem solving that we do, sometimes it's going to be better to round to one place value place as opposed to the next, and it's going to kind of be up to you to decide. There's not really going to be a right or wrong answer per se, but there are going to be some answers that are better than others. So let's take a look at some problems and see how we can use rounding to help us make some good estimates. Alright, here we have a problem that says in the year 2012 there were 935,292 visitors to the White House. Okay, the number looks familiar, right? Assume that each visitor was given a map. So everybody that comes into the White House that visits gets a map of the White House, right? Use this information to predict the number of White House maps needed for visitors in 2013. So we know the 2012 number, which was this, our 935,292. We want to assume that everybody gets a map, so all of these visitors, they all got a map, right? So using that, how many maps are they going to need for 2013? So in 2012, they needed 935,292. About how many maps do you think they're going to need for 2013? Now again, there's not really a right or wrong answer to this. There's going to be some answers that are better than others, but as long as you can kind of think through the process and explain what you're thinking, your answer can be valid as long as you can back it up. So having the information that we have here, I want you guys to take a second and think about where would you round this number to estimate the amount of maps that you would need for 2013. Would you round to the 100,000s place, the 10,000s place, the thousands place, the hundreds place, the tens place, or the ones place? Where would you round to make a good estimate on how many maps you would need? Keep in mind that you're not going to see the same number of visitors every year. You're not going to get that same exact amount of visitors, right? That would be nice if you knew in advance, but you might not get that same amount. So about how many maps do you think we would need? What would be a good estimate? Go ahead and think about that. Talk about it with your learning guide, with someone close to you, and kind of discuss it a little bit. And then we'll come back together and share what we've got. All right, well, I hope you guys had some great discussions out there. I saw some stuff that you posted, which was awesome. So I'm going to explain a little bit about my thinking and see if you guys agree, disagree. And again, like I said, it's okay to agree and to disagree a little bit, as long as you can kind of validate your answer, kind of explain why it is that you thought that, okay? So here I wrote down my 935,292. I wrote it 3 times, and I rounded it to 3 different places just so you could see my thought process here. All right, so starting with our first number here of 935,292, I rounded it to the 100,000s place, okay? And that rounded to 900,000. Now, the reason I don't really like this one as an estimate is because it's kind of way below what they used in 2012. So in 2012, they had 935,292. If I ordered just 900,000, I'd be short this 35,292 if we got the same amount of visitors. Now, we could get less visitors, right? That could possibly happen. But my kind of saying when it comes to stuff like this is better safe than sorry, right? You better have what you need just in case. If you have extra, great. But if you need more, it's going to be hard to get those on a short notice, right? So this estimate, although it's not wrong, I don't think would be the best estimate, okay? So I'm just going to put a line through this guy. If I come over here, 940,000, that's when I estimated or I rounded to the 10,000s place, okay? When I round to the 10,000s place, I get 940,000. Now that one's pretty close to what we have, okay? 940,000, I'd only be about 5,000 maps over what they used in 2012. So to me, that's pretty close without going too crazy over or too crazy under. It's right about where it needs to be. So this guy right now is looking like my best estimate, okay? And then if I move down to this guy, these should all be zeros. Sorry about that. But if I move down to this guy, again, I rounded to the thousands place here, and I got 935,000. Not a bad estimate, but again, it's a little bit under what we had, only 200 under, so it's not terrible. So you could definitely go with this one or this one. Either one of these I think would be decent estimates. This guy right here I think is a little bit under or way under where we need it to be, okay? So you can see how depending on what place value you round to, you might get a better estimate depending on the scenario that you're working with, all right? Let's take a look at one more real quick, and then I'll let you guys move on. All right, so this one says that 2,837 children attend Lincoln Elementary School. So how would you estimate the number of chairs needed in this school? So if we have 2,837 children, and you wanted to get an estimate on how many chairs you would need for those kiddos, what would you do? Where would you round to? How would you kind of defend your answer there? What would your estimate be? I want you to take a second and discuss that with a learning guide or someone in your house, and then you're going to discuss it online with your classmates. And then we'll get back together and we'll kind of talk about where we're at. All right, so hopefully you had some time to discuss and to share what you thought and to kind of think through what you thought. So looking at this problem again, we know about 2,837 children attend Lincoln Elementary School. Now, if that was an exact number, obviously we could order that many chairs, right? That would make the most sense. But let's pretend like that's an approximate number and we're trying to plan for next year, we're going to get new chairs, right? So about how many chairs do you think we should order? Now, when I round this number to 3 different place values here, I rounded to the thousands, I rounded to the hundreds, and I rounded to the tens. I get 3 different numbers, right? When I round to the largest place value, that thousands place, I get a number bigger than what I started with. In the last example, we got a number smaller, right? So that one didn't work. But in this one, I get a number bigger. So this isn't a bad estimate, but it's almost 200 more than what I may or may not need, okay? It's 200 more than the kids that we had last year. So again, it's not a bad estimate, but depending on how much the chairs cost and how much you really want the chairs, and what you can do with extra chairs, this might not be your best estimate. If I come over here and I round to the hundreds, again, that's pretty close, right? 2,800. It would only be 37 less than what I needed. So again, it's not a bad estimate. It's pretty close to where we need it to be. But I'm wondering if we can get a little bit closer. So here I rounded to the tens place. When I round to the tens place, I get 2,840. To me, this might be the best estimate because the number of kids at a school shouldn't change too much from year to year. So I can get it pretty close. I might have 3 extra chairs. That's not much. Okay, I can deal with that. But really, any of these estimates aren't bad estimates. But you can see how much they vary from place value to place value. Here you're going to end up with, if you get the same amount of kids, you're going to end up with almost 300 more chairs. Here you're not going to have quite enough chairs, and here you're only going to have a few extra. So really, the place value that you round to could have a big impact on what your estimates are. So just kind of keep that in mind when you're problem solving. That was the goal of today. Just kind of see how when we do estimate, that place value that we choose could definitely have an impact on our outcome and our estimate. So kind of keep that in mind as you're doing some problem solving and going through these things. So you're definitely going to have to look at your problem, look at the situation that it's explaining to you, and choose the best place value based on that situation, and be able to back it up with some reasoning that you have, okay? So hope you guys enjoyed this lesson. Please let me know if you have any questions, comments, or concerns, and I thank you very, very much for participating. Talk to you soon.